Okay, also, like I said, 8.4 is theorems about the zeros of polynomials. All right, so for the first few examples, they're going to give us some zeros and they want us to find a polynomial function. So when they give you the zeros and they want us to find a polynomial function, it's like we're working in reverse. We're going to start with the solutions and then work backwards until we can get us a polynomial, okay? So for this first one, they want to find a polynomial of degree 3 with real coefficients that has the given zeros. All right, the zeros they're giving me are -2, 3, and -4. So they're giving me the zeros, which are the solutions. So they want us to work in reverse and come up with a polynomial. And they're saying degree 3. So when we're done, 3 is the highest exponent that we can have in this function, okay? So what we do, they're giving us 3 answers. We're going to set them up as x equals -2, x equals 3, and x equals -4. Now we're going to work in reverse. So if we're going to work in reverse, we need to get a 0 on the right side of all these equations and rewrite it as factors equal to 0. So we need to get 0 on the right side. Of each equation. All right, so that's my first step. Get a 0 on the right side. So for the first one, I'm going to add 2 to both sides. And I get x plus 2 equals 0. Second one, I'm going to subtract 3 from both sides. And I get x minus 3 equals 0. And y'all finally, the last one, I'm going to add 4 to both sides. So I get x plus 4 equals 0. Now, we're going to work off of what we call a zero product rule. And the zero product rule says that I can set all 3 of these factors together on one side. So I'm going to put each of my factors in parentheses and set that whole thing equal to 0. So you see how we're working in reverse? We're starting with the answers. Now we got the factors all equal to 0. Now, we got 3 sets of parentheses equal to 0. We're going to start foiling this. So y'all, the first 2 I'm going to foil. I always foil the last 2 first. So I'm going to bring down my x plus 2. So on the side here, on the side, I'm going to foil x minus 3 times the x plus 4. I'm going to foil this out first and then put that answer right here. So y'all, if we foil this, x times x is x squared. X times positive 4 is a positive 4x. -3 times x is a -3x. And then that -3 times 4 is a negative 12. I'm going to add like terms in the middle so that I get an x squared. 4 minus 3 leaves me 1x, and then minus my 12. So I'm going to now put that over here, x squared plus x minus 12. All this is still set equal to 0. So now I still got parentheses that I got to multiply through. So now I'm going to multiply the first parentheses times the second one. So we're going to multiply again, and it's sort of like foiling, but it's a little bit bigger. So the first thing we do, we're going to take this x and multiply by all three of these in the second parentheses. So the x times x squared gives me an x to the third. X times x gives me an x squared. The x times negative 12 gives me a negative 12x. Now we take the 2 and we're going to distribute it just like we did the x. So 2 times x squared is a 2x squared. 2 times x is a 2x. 2 times negative 12 is a negative 24, all equal to 0 still. At this point, all we can do is add like terms. So the x to the third has nothing to add to, so bring down the x to the third. You got an x squared here. It'll add to the 2x squareds. So 1 plus 2 is going to give us 3x squared. This negative 12x will add to that positive 2x. So negative 12 and positive 2 give you a negative 10x. And y'all, the only other thing I got left is that minus 24. All equal to 0. Now, MathLab on this one, they have f of x equals x to the third plus blank x squared minus 10x minus 24. So on that one, they gave you most of the answer. All we had to do was come in and put that 3 in the box. So now we got our x to the third, 3x squared, minus 10x, minus 24. So on that one, like I said, MathLab will give you most of the answer. You just got to fill in for whatever's missing on their equation, okay? And y'all look at that. The highest exponent is a 3, so it's a degree 3, like they said. Okay? So that's the trick on these. It's just we're going to be working in reverse. All right, and so this one just says write a polynomial with zeros of 2, 4i, and negative 4i. So now we get to play with some imaginary numbers on this one. So the trick on this, I'm going to set my 3 answers equal to x. So I'm going to have x equals a 2, x equals 4i, and x equals negative 4i. All right, once again, we want to get a 0 on the right side like we did up there. So we're going to add and subtract. So we're going to subtract 2 on the first one. I'm going to subtract 4i on the second one. So if you notice, I'm just adding the opposite to each side. And then here I'm going to add 4i. All right, y'all, so I got 3 equations equal to 0. So now I'm going to do like up here and put them all in parentheses equal to 0. So I'm going to bring down my x minus 2, x minus 4i, x plus 4i, and set all that equal to 0. Now, when you FOIL this, you want to start with this imaginary stuff. And you'll see when I start FOILing this, but always FOIL the imaginary numbers first. This will get really ugly if you try to do the x minus 2 times one of these, okay? That'll get a little bit ugly. So on the side, I'm going to do x minus 4i times x plus 4i. These are what we call conjugate pairs. And y'all, the nice thing about conjugate pairs, when you FOIL them, some of the terms cancel out on these, okay? So I'm going to FOIL this all the way out so that you see what happens. So I'm going to do x times x is an x squared. X times 4i is a 4ix. Now I'm going to distribute the negative 4i. That negative 4i times x is a negative 4ix. And y'all, here we go. The negative 4i times 4i is a negative 16i squared. Now, y'all, there's something you got to realize about this problem. Look here in the middle. You got a 4ix and a negative 4ix. Those terms in the middle cancel. And y'all, here's a question for y'all. I squared, if you get an I squared in your problem, I squared equals a negative 1. Y'all remember that? I squared equals negative 1. So if I get an I squared in my problem like I got here, I'm going to replace that I squared with a negative 1. So that this becomes a x squared minus 16 times negative 1. So notice, I turned that I squared into a negative 1, like I said. So bring down the x squared. And y'all guess what that negative 1 is going to do to that negative 16? 2 negatives make that a positive. So when you FOIL 2 imaginary numbers that are conjugate pairs like this, you're always going to end up with an x squared plus whatever number. All right, y'all, so bring down your x minus 2. The x minus 4i, x plus 4i gave me an x squared plus 16. All equal to 0 at the moment. All right, so now I got 2 things times 2 things. I'm actually going to FOIL these ones. And y'all, since this is the last thing I'm going to FOIL, I'll just do them right here, okay? Instead of on the side. All right, y'all, so let's see what we get. X times x squared is x to the 3rd. X times 16 is 16x. That negative 2 times x squared is a negative 2x squared. And then finally, that negative 2 times 16 is a negative 32. Now, this one, I'll show you how they got the answer. They got f of x equals x to the third minus blank x squared plus blank x minus blank. So more blanks on this one than on my first problem up here. So let's see. We got our x to the third in the front. So this gives me a. Now remember, I'm out of order up here. My x squared is going to be the negative 2x squared. So make sure you put them in order down here because they're going in descending order. Now my x's was the 16x. So bring down my 16. And then at the number at the end, it was minus. Well, my number at the end was 32. So remember, when you go from your polynomial to their answers, they're always going to have theirs in descending order. So if you notice, the moral of today for right now is a lot of foiling, okay? All right, so this one says, find the polynomial function of lowest degree with zeros of square root of 2, negative square root of 2, and 4. So we did imaginary numbers a while ago. Now we're doing radical numbers. All right, so here we go. We're going to have x equals a square root of 2. X equals a negative square root of 2. And then x equals 4. So get a 0 on the right side by adding and subtracting. So the first one, I'm going to subtract square root of 2 from both sides. X minus square root of 2 equals 0. The second one will add a square root of 2. I get x plus a square root of 2 equals 0. And the last one looks like we'll subtract 4 from both sides and get x minus 4 equals 0. So basically, I'm changing the sign of these and putting them on the other side and throwing a 0 on the right side, okay? So now, we're going to put all these in parentheses. So y'all, a while ago, I was picky with the imaginaries. I always start by foiling the imaginary stuff together. Well, on this one, I'm going to start by foiling the radical stuff. Because once again, these are conjugate pairs. And when you foil conjugate pairs of radicals, it gets rid of the radicals in the long run. So let's go to the side and foil this. So x minus square root of 2 times x plus square root of 2. Now here's the big thing about radicals. When you multiply radicals, the inside numbers can only multiply by inside numbers. Stuff under a radical cannot multiply by stuff outside the radical, okay? That means you got to keep the stuff outside the radical outside and the stuff inside that radical. So y'all watch what I mean. Right here, I got an x times an x. That's going to give me an x squared. This x times the square root of 2, that's going to be a square root of 2 times x. But notice, this x is not under that radical with that 2, okay? Now do the negative square root of 2 times x. I'm going to get a negative square root of 2 times x. And then finally, the negative square root of 2 times the square root of 2 is a negative square root. So now this 2's underneath, it can multiply by that 2 that's underneath the radical. And 2 times 2 makes that a square root of 4. All right, y'all, watch how the radicals disappear. Look in the middle. You got a positive 2 square root of 2, negative square root of 2. Those are going to cancel. So bring down your x squared minus, well, y'all, what is the square root of 4? Square root of 4 is a 2, so that comes out as
2.
And there you go. That comes out as an x squared minus 2. But notice, the radicals are gone. So y'all, the first half of this gave us our x squared minus 2. We still got that x minus 4 at the end, and all this equal to 0. So here's the thing. A while ago, when I multiplied the I stuff, the imaginary numbers, they ended up as an x squared plus a number. When you FOIL conjugate pairs of radicals, it always ends up as x squared minus the number, okay? So imaginary stuff always ends up positive. Radicals always end up negative. All right, y'all, so I got 2 things times 2 things, so I get to FOIL. So you're foiling quite a bit on these problems. Notice each of these first 3 problems, I foiled twice on each problem, okay? And if you notice, every time they give me 3 zeros when I started, when I'm done, my highest exponent was a 3, okay? All right, y'all, here we go. X squared times x is the x to the 3rd, which we knew we had to get an x to the 3rd because we had 3 zeros. All right, x squared times negative 4 is a negative 4x squared. I got a negative 2 times x, which is a negative 2x. And then y'all, finally, that negative 2 times negative 4 gives me a positive 8 equal to 0. So on this, and all MathLab wants is the actual function, which is a x to the 3rd minus 4x squared minus 2x plus 8. So on that one, they give you like 4 answers, and you just got to pick the one that matches ours. So y'all, that is how you find a polynomial if I give you some of those zeros, okay? So let's look at some other special things about these zeros here, okay? Other theorems about zeros. Well, the first one deals with these radicals. So this one says radical zeros. So radical zeros will be like this square root of 2 they gave me a while ago, and this negative square root of 2 they gave me. But y'all, radical zeros always come in conjugate pairs. Right, trying to find my better pen. Radical zeros always come in conjugate pairs. That means if square root of 5 is a 0, then a negative square root of 5 is also a 0. And that's why when we did the radicals, they gave me a square root of 2 and a negative square root of 2, because those always come in conjugate pairs. If 3 plus square root of 7 is a 0, then 3 minus square root of 7 is also a 0. So I can write it as a radical by itself, square root of 5. Its conjugate would be a negative square root of 5. If they give me this form, 3 plus square root of 7, then 3 minus square root of 7 is a 0. Notice, the 3 don't change signs on this one. Only the stuff with the radical changes sign. And y'all, that's because the square root can be either positive or negative, remember, when you're doing them square roots, okay? All right, also, imaginary zeros always come in conjugate pairs. So imaginary zeros always come in conjugate pairs. So what I mean by that, if a negative 5i is a 0, then a positive 5i is also a 0. Okay, so it could be a negative 5i. That automatically means that a positive 5i is a 0. Also, if something like negative 2 plus 3i is a 0, then negative 2 minus the 3i is also a 0. So you got to remember that now. If I give you one of these two forms, you automatically got to assume that the other one is a 0 also, okay? Because the radical stuff and the imaginary always come in conjugate pairs. All right, y'all, so let me show you some examples doing that in a second and let y'all catch up. All righty, so all right, y'all, so think about this one. Suppose a polynomial of degree 4 has zeros of negative 5, a square root of 5, and 7/4. They want us to find the other 0. So y'all, do y'all have on any ideas at all of what my other 0 might be? They're giving me a negative 5. They're giving me a square root of 5, and they're giving me a 7/4. Now remember, that's a degree 4, so I know I got 4 zeros. So what's the missing?
Would it be negative square root of 5?
Oh, perfect. Negative square root of 5. You know, that's all we had to do on that. And so good job, because the ones that comes as conjugates was that radical. All right, so same thing. Suppose a polynomial degree 4 again has zeros of a negative I, comma, 7 minus square root of 11. Then they say, hey, find the other zeros. So remember, this is a degree 4, so I need 4 zeros altogether. They're giving me 2. They're giving me a negative I, and then remember, this is a single number, 7 minus square root of 11. So what y'all think about that one?
Positive I and 7 plus the square root of 11.
Perfect. Right? So the conjugate pair of negative I was the I. Good job. Conjugate of 7 minus square root of 11 was a 7 plus. All right, one more of those, then we'll move on. All right, same thing. Suppose a polynomial degree 4 has zeros of, oh, y'all, let me see, 2 plus 5I and 5 plus square root of 2. Find the other zeros. All right, let's see what you say.
2 minus 5I and 5 minus the square root of 2.
Damn, good job. So not too bad, are they? But y'all, they wanted y'all to know this stuff here for my next problem. So check this out. Because now we're going to go back to finding them polynomials. But look how they do this. They say, find a polynomial function of lowest degree that has a negative 4i and 6 as some of its zeros. So here's the thing on this one. They're telling me lowest degree because they don't want to give it away as to how many zeros I should actually have. They're trying to throw me a curveball. But we know that we're going to set x equals negative 4i down here. Well, y'all, if I put x equals negative 4i, what else do I need?
Positive 4I.
I need a positive 4i. So that's going to be x equals 4i. And then my last one will be the x equals 6. So that's where they're going to try to throw you curveballs with that stuff, is that if they give you these imaginary zeros, then you automatically got to put those conjugates in there, okay? All right, then we're going to what? Get a 0 on the right side by adding 4i to the first one. Subtract 4i from the second one. And then what? Subtract 6 from our last one. All right, y'all. Got 3 factors. Put them all in parentheses. So y'all, I'm going to start with the first 2 because I always start with this imaginary stuff. And I'm going to FOIL it. So I'm going to FOIL it on the side here. X plus 4i, x minus 4i. Now remember, when you FOIL these, it's always going to cancel out those middle terms because they're conjugates. So the x times x is an x squared. X times negative 4i is a negative 4ix. Positive 4i times x is a positive 4ix. And then y'all, 4i times negative 4i is a negative 16i squared. So y'all notice once again, those cancel in the middle. I'm going to bring down the x squared minus the 16. Do y'all remember what the I squared equals?
-1.
-1. And if you notice, the only purpose of that I squared in life is to change the sign of whatever number's in front of it. So bring down your x squared. That 16 was negative, but when you multiply by that -1, we'll make it a positive 16. So the imaginary stuff always has to end up positive, okay? So y'all, let's fit that in here. X squared plus 16 takes care of those. And then I still got my x minus 6. All this equal to 0 at the moment. So if you notice, all we got left is to FOIL these two now. So if you were weak at FOILing before today, after today's homework, you'll be pretty good at it, okay? Because that's all you're doing. A lot of this is FOILing. All right, y'all, let's see what we get. X squared times x is x to the third. X squared times -6 is a negative 6x squared. All right, then I do my 16 times x is a 16x. And then finally, 16 times -6 is a negative 96. All equal to my 0. But let's see, MATLAB, they'll give you the f of x. All they want is the polynomial. x3 minus 6x squared plus 16x minus 96. So I was lucky on that when it was already in descending order. So put that in MATLAB and be done. All right, so the moral of this problem was to realize that I had to bring that conjugate pair down, okay? All right, I'll give y'all a second, then I'll spin it over. All right, so let's try another one now. Y'all, that's why we're only doing 8-4 today, because it's a lot of FOILing in this, okay? So y'all, let's see what we do on this one. So once again, find a polynomial lowest degree. With a square root of 5 and a 5i as some of its zeros. So once again, they're not telling me my degree because they don't want to give away how many zeros I should have. But let me make that. That's the square root of 5 and a 5i. So if I got x equals a square root of 5, what's the next zero going to be?
Negative square root of 5.
So there you go. That's going to be a negative square root of 5. And then if I got this x equals 5i, then I also need a what?
Negative 5i.
A negative 5i. So this time they only gave me 2, but in fact, I've got 4 of these, okay? So I always put this radical stuff together and I always put these imaginary ones together. So let's add and subtract to get our zeros. So we'll do minus square root of 5 on the first one. Plus square root of 5. I'll subtract 5i on the third. And then finally add 5i to that last one. All righty, so now I'm going to put all 4 of these in parentheses. Now, y'all, I'm going to do 2 of these at a time, and I'm going to show y'all some shortcut methods. So I'm going to, since these are conjugate pairs and those middle terms always always sort of canceled out, I'm going to show y'all how to shortcut FOIL. Only when you got conjugate pairs, and remember, conjugate pairs got to look the same other than one's subtracted, one's added. So these are conjugate pairs also. So I'm going to show you how to shortcut FOIL that one also. So let me start with my first one. Shortcut FOIL, we multiply the first 2 terms together. So you're going to multiply the x into x and get an x squared. Now notice, next, I'm going to multiply the last 2, the radical stuff together. So a negative square root of 5 times a positive square root of 5 is a negative square root. 5 times 5 is 25. All right, so that's the first one. And now I'm going to do another step in a second with that square root of 25, okay? So, but let's first play with this one. Shortcut FOIL, the first 2, x times x is an x squared. Negative 5i times 5i is a negative 25i squared. And if you notice, I can go 1 step further in this one. So I'm going to have x squared minus square root of 25 is 5. Now, y'all, what did we say about this I squared? Y'all said the I squared equaled a negative 1. So bring down that x squared. That negative 1 that we're replacing that I squared with, that negative 1 times negative 25, we'll make that a positive 25. So just remember, at this point, I'm replacing I squared with negative 1, okay? All right, y'all, so 2 things times 2. Now I get to FOIL this out. Now, these are not conjugate pairs, so we got to actually FOIL it all the way out, okay? So here we go. X squared times x squared is x to the 4th. X squared times 25 is a 25x squared. All right, now I got negative 5 times x squared is a negative 5x squared. And y'all, finally, that negative 5 times 25 is a negative 125, all equal to my 0. And y'all notice I can go 1 more step further because x squareds and x squareds, those are like terms right here. So once we add the like terms, we should have our final answer. So let's see, we're going to bring down the x to the 4th. 25 minus 5 gives me 20x squared. And then bring down that minus 125 equal to 0. Oh, and y'all remember the last thing they do, they'll put the f of x here. And all we're doing is putting in our x to the 4 plus 20x squared minus 125. So conjugate pairs can be shortcut foiled. But when you do not have conjugate pairs like this, you actually got to fold it all the way out, okay? All righty, y'all. So y'all remember we did some synthetic division yesterday. So the next few problems deal with how to find zeros. So y'all watch this. The polynomial has a given zero, a given zero of -3. They want me to find the other zeros. All right, so now my function is going to be f of x equals, what I got, x to the third plus 3x squared minus 5x minus 15. Now, in math side, they put a semicolon and then the -3, okay? So they sort of worded it a little different than me, but you're still given a zero of -3. So here's what we do. When we got an x to the third, we got to do synthetic division one time. And then when we get those coefficients under the box, we can do the quadratic formula to get the last two zeros. Now, if this would have been with an x to the 4, I would have to do synthetic division twice to get it to where I can do the quadratic stuff, okay? So what I'm going to do here, since I know a zero is -3, I'm going to put -3 as my c, and then I'm going to write out the coefficients of my function, which are 1, 3, -5, and -15. Now remember, I got my remainder over here. So since this started out with a degree 3, remember these coefficients will be a degree less, which will be a 2. And anything that's quadratic, I can solve using quadratic formula, square roots, and all that fun stuff. Now, let me ask y'all this question. If -3 is a zero of this polynomial, what does that remainder have to be when I'm done?
A 0.
What did you just say? I think he was right.
A 0.
A 0. Because remember, that's how we was checking them yesterday. And that's why we were doing synthetic division yesterday. And we were checking to see if numbers were zeros, if they had that 0 remainder. Good job. All right, y'all. So we know, but what we're interested in is what 3 numbers we get here so that we can do the quadratic stuff. So if you remember the first number, the 1 we brought all the way down. And then we're just going to start multiplying through. So 1 times -3 was -3. 3 plus -3 gave me a 0. 0 times -3 is 0. -5 plus 0 is -5. And look at that. -5 times -3 is a positive 15, which gave me a 0 remainder. So if you remember, we said this was the coefficients 1 degree less. So that means this is your x squared term, your x term, and the number. But y'all watch this. 1x squared. 0x is in the middle, so I don't got to write the x's. And then I got -5. So that's what these 3 numbers gave me. 1, 0, -5. to find my last two zeros. I'm going to set that equal to 0 and solve for my x. So we already know -3 is a 0. We checked it. We got a 0 remainder. Now to get the last two zeros, well, there's not an x term in the middle. So when I had an x squared and just a number, the easiest way to do this is to add 5 to both sides, get that x squared by itself. So I'm going to get x squared equals 5. And y'all remember, to turn that x squared into an x, we're going to take square roots of both sides. So that's going to give me my x. So the question is, can we do anything with that square root of 5?
No.
No.
No, but there's one thing we got to put in the front of that.
And I plus or minus.
Oh, there you go. We want that plus
Plus or minus.
minus. There you go. So if -3 was a 0, the other two zeros, or how about the other zeros, are, now you can do plus or minus square root of 5 in math lab, or you can do a plus square root of 5, comma, negative square root of 5. All right, y'all, so let's play with one more of those before we go on a break. All right, so for the polynomial, one zero is given. They say, find the other zeros. All right, y'all, so watch how they write this. They got P of x equals x to the 4th plus 16x squared minus 225. Then they got a comma that says 5i is a 0. So y'all, since 5i is a 0, my first C is going to be that 5i. But here's where you got to watch out for. Over here. Because look, you got an x4 term. That'll be a 1. I do not have an x3 term. So do y'all remember what I got to put when I don't have an x3 term?
0.
There you go. You got those zeros in for anything missing. I got my x squared term. That's a 16. But y'all look at this. I don't have an x term here. So since I don't have the x term, I got another 0. And then my number at the end was a -225. So whatever the highest exponent is, add 1 to that, and that tells you how many numbers you need. Once again, 5i is a 0, so I know I better get a 0 here, okay? So watch this. We're going to bring down to 1. 1 times 5i is 5i. 0 plus 5i is 5i. All right, y'all, so let's see what we got here. We got a 5i times a 5i. That's going to give us, watch this, 5i times 5i. That's going to give us a 25i squared. But we're not going to write that here. Because what does 25i squared really equal?
-1.
So the I
No,
squared,
it's a -1.
so the I squared is -1, which makes this whole thing a -25. So bring in that -25. So remember, that's only I squared's purpose in life is to change the sign of that number in front of it. So y'all, we got a 16 and a -25. That's going to give me what, a -9? -9 times 5i is a -45i. All right, watch this. 0, -45i is a -45i. So now look what we got. We got -45i multiplying by a 5i. That's going to give me a negative, looks like what? -225i squared. So y'all, in the long run, what does a -225i squared equal?
Positive 225.
Positive 225. Good job. And guess what? That's what I needed there, right? Because I got a -225. Positive 225 gives me a big remainder of 0. And y'all, here's the thing on this one. We started with an x4. So this is really an x3 term, x squared term, x term, and then my number. So I'm not small enough yet to do that quadratic stuff because I still got an x3 sitting here. So we're going to use these numbers that they gave us as our next coefficients. We're going to do 1, 5i, -9, -45i. Those are going to be our next coefficients we're going to use. Okay, so whatever's under here as the quotient becomes the next coefficients of our synthetic division. Oh, snap, y'all. One thing I got to figure out, though. What number can I check next for my next 0?
-5i.
Oh, my God. Perfect. Because they gave me 5i, we automatically got to assume that -5i is a 0 also. Which means, y'all, when you get done with this, we better have a 0 sitting here, okay? So let's see what happens. We're going to bring our 1 down. 1 times -5i is a -5i. And y'all look at that. 5i, -5i, big 0. 0 times -5i is 0. -9 plus 0 is -9. And y'all look at this. That -9 times that -5i, that's going to give me a positive 45i, which when I add up gives me my 0. So we now know they gave me the 5i. We now know that -5i is a 0. Now, since these coefficients started out as x3s, that means what's left now is an x squared term, x term, and my number term. So this is like x squared. I don't got to put the 0x. So it's like an x squared minus 9. I'm going to set that equal to 0. So notice once again, x squared term in a number. I'm going to add the number and do my square roots. So we get x squared is now a positive 9. Take square roots of both sides. So x will be what? A plus or minus. Oh, and we can actually bring this one out. Square root of 9 is a big 3. Now, here's what MathLab wants. MathLab wants the other zeros. But y'all, don't put the 5i because they gave us the 5i. We want to start with our -5i. And then we can do the plus or minus 3. Or you could do -5i, comma 3, comma -3, okay? All righty, y'all. So Notice on these ones, they gave me some of the zeros. Now, for the last two I'm going to do after break, well, unfortunately, they're not going to give us any zeros. So I'm going to show you how to find zeros when they don't give you any zeros, okay? So let me stop the share, and I'm going to pause it today instead of stop it. All righty, so notice the two problems that we just did, they gave me a zero to start with, and then I had to find the other zeros. For these last two problems, they're not going to give us any of the zeros. So we got to figure a way to find some of the zeros and then start doing our synthetic division. So for this one, it's got a part A and a part B. Part A, they want us to find the rational zeros and then the other zeros of f of x equals x to the third minus 133x plus 132. So the rational zeros are the ones that are like numbers and fractions. The other zeros will be the radicals or the imaginary, okay? Now, part B, they want us to factor into linear factors. And I'll show you what they mean by that, okay? Now, I'm going to show you all a way that we can guess what the first zero is. We can graph this. And when I graph it, I'm going to look for places where my graph is crossing the x-axis. If I can find where the graph crosses the x-axis, that'll give me a zero to start with, okay? So I'm going to go to my calculator and graph this. So I'm in y equals, I'm going to do my x to the third. So x exponent 3. Then I'm going to arrow down minus 133x plus 132. So I just want to graph this so that I can see if I can find any of my zeros, okay? So let me hit graph. And y'all, all I see is one line from that graph, but can you tell what number it looks like that thing's crossing over?
1.
Looks like it's crossing over at 1. And y'all, if I want to verify that, I can go to second graph and look at my table. And let me arrow up to where my x is 1 at. And if you look at that, when x is 1, y is in fact 0. So that means the first zero I'm going to try is 1. So my first C will be 1. Now remember, this is an x to the third. So once I do synthetic division one time, I'll have 3 numbers that I can do my quadratic stuff for, okay? Now be careful. X3 term is a 1.
If it gives you more than one line on the graph, do you just choose which one to use?
Yeah. Now, like the one I'm going to do in a second, that's going to be an X4. It should have 2 places where it's crossing over, so I'm going to use both of those.
Because my problem on MathLab that I put in, it gave me 3 points.
Yeah. So that,
and I checked the chart and all that, and it's still the points are still right and all that. So yeah. I was wondering if I just choose one.
Yeah, you can choose any one of them, but all three of those would be your zeros, in fact, probably.
Okay.
Okay. All right, y'all, look at here. I don't have an x squared term, so I'm going to use a 0. My x is a negative 133. And then my number at the end is a 132. Now, if I got the right 0 here, then my remainder better be 0, okay? So here we go. We'll bring the 1 down. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 133 plus 1 is a negative 132. And y'all look at that. Negative 132 times 1 is a negative 132, which gives me a 0 remainder. So I know my first 0, and this is a rational 0 because it's a integer type number, okay? So now, this time I got 3 numbers. Remember, this is like a x squared here and my x. So I'm ending up with an x squared plus the x minus the 132. I'm going to set that equal to 0. So y'all, sadly on this one, I can't do the square root stuff because I got this x in the middle. So the only other choice I got is the quadratic formula. So A is 1, B will be 1, and C will be a negative 132. So once I do the quadratic formula, it'll give me my last 2 zeros, and then I can start answering the questions. So the quadratic formula, x equals negative b, which is 1, plus or minus square root b squared, that'll be 1 squared, minus 4 times 1 times that negative 132. All of that over 2 times my a, which is 1. All right, so if you notice, I got a lot of work up under my radical there. So that's going to make this a negative 1 plus or minus square root. 1 squared is 1. And y'all look at this. The whole right side, negative 4 times 1 times negative 132. 2 negatives will make that into a positive. And y'all, let's see what we get. 4 times 1 times negative 132. That's going to give me a positive 528. All over 2 times 1 is 2. All right, y'all, let me do something on my math real quick. All righty, so next thing I would do, I got negative 1 plus or minus 1 plus 528 is 529 all over 2. All right, y'all, so let me check something. Y'all, this is a perfect square. If you punch square root of 529, you will get a 23. All of that over 2. All right, y'all. So to get my 2 answers, my first answer, I would do negative 1 plus 23 divided by 2. So the first time you use the plus to get your answer. Well, negative 1 and 23 gives me 22 over 2, which will give us 11. To get our second answer, we use the subtraction. So negative 1 minus 23 over 2 will give me a negative 24 over 2, which gives me a negative 12. So when you graph that, Walgo, you should have crossed it at 1, and then you was crossing it at 11 and negative 12 also on that, okay? So that would have been the 3 points that you were looking at when you seen the graph. So all these are regular numbers. So these are all, when you put it in, the rational zeros are going to be 1, 11, and -12. You didn't have any other zeros on that one, okay? The other zeros would be stuff, like I said, imaginary and radicals. So part B, it said the factorization f of x equals, now when they're talking about putting it in linear factors, they're just talking about putting everything in parentheses. Now, if these are my 3 zeros, remember when we put them in parentheses, the first one, since that's a positive one, the first factor will be a -1. Remember, these linear factors always had opposite signs than the zeros. So that was a positive 11. This factor will be x minus 11. And then this 0 was a -12. So this factor will be a x plus 12. So that's all they mean when they say linear factors. They just want you to put them in parentheses and change the sign of them zeros, okay? So if you notice, when you did graph that and you had the 3 lines on your graph, those were your 3 answers. You didn't even have to do all this work if you could actually see on the graph where those 3 zeros were, okay?
I didn't on my problem. I just wrote down yours just in case I didn't get that one time.
Uh-huh. Yeah, so yours was fine. Mine would have showed up if I'd have extended my window just a little bit. I would have caught those other 2, okay? All righty, so let me show you one with a x4 in the beginning. And y'all were doing the same thing. So, but this time they're giving me f of x equals x to the 4th minus 7x to the 3rd minus 35x squared minus 41x minus 14. Whoops, let me move my camera. All right, now y'all can see it.
Can you show us how to put it in on MATLAB?
Oh, well, MATLAB, it'll just have the answer like I just had over here. MATLAB will say rational zeros. So MATLAB's giving you, let me show you right here. I'm going to zoom this in just a little bit so y'all can see what I got here. So MATLAB will give you A, B, or C. It says there are only rational zeros, and that's what we had, only rational zeros, because we had 3 numbers. Choice B would have been if I had rational zeros and either imaginary or radical. Okay. And then that was the factorization. So right here, our numbers were what? 1. We'd have put in a 1, 11, and a -12. Then it probably would have said check that answer or whatever. Then down here where it says the factorizations, that's where I'd have put my parentheses, x minus 1, x minus 11, and x plus 12. So you just choose which A, B, or C for the first part, write your zeros, and then the second part, you're just putting them in parentheses. Now, the next one I do, it's going to have both types of zeros, and I'll show y'all how I would put that answer in also, okay? So I'm going to go graph this because I have no idea where these zeros are. So let's go graph it. Now remember, this is starting with an x to the 4th. So I'm hopefully going to be able to find 2 places where it's crossing that x-axis. So I'm going to go to y equals and clear this out. Woo, then I'm going to put an x to the 4th, arrow down, minus 7x to the third. Arrow down. Minus 35x squared minus 41x minus 14. All right, y'all. So let's hit this graph and hopefully we can find at least 2 places where it's crossing that x-axis. Because I'm going to need 2 zeros since I got 4. All right, so I'm looking on the left side, and y'all, what would y'all say them 2 points are where I'm touching that x-axis?
-2 and -1.
Yeah, -2 looks like a -1. And if we want to verify that, we're going to go second graph to the table. And if I arrow up to where there's -1 at 0, -2 at 0. So we got 2 zeros we can try, -2 and -1. So y'all, I'm going to start out with -1 first. Once I get my next polynomial, I'll do that -2. And then the last 2, I can either do some kind of quadratics for. All right, let's see. X4, X3, X2, X, and number. Nothing's missing. So I got a 1, -7, -35, -41, and a -14. All right, y'all bring the 1 down. 1 times -1 is -1. -8, -7 and -1 give me -8. -8 times -1 is a +8. -35 and 8 is a -27. -27 times -1 is a +27. And y'all look at that. -41, 27, give you -14. But that -14 times that -1 makes that a +14 and gives me my remainder of 0. So remember, that was an X4. So this is now an X3, X2, X, and my number. So I'm still too big to do my quadratic formula stuff. So I'm going to write these 4 numbers down. 1, -8, -27, and -14. Oh, and y'all, do y'all remember my second number? I forgot. I don't want to have to go back to my graph. So what was that other number y'all told me?
-2.
Negative 2. There you go. So -2 better give me a 0 here. If I get a 0, then I'm going to have my 3 numbers and do my quadratic stuff. So bring that 1 down. 1 times -2 is -2. -2 plus -8 is -10. -10 times -2 is what, a 20. -27 and 20 give me a -7. And here we go. -7 times -2 is a +14, which gives me a 0 remainder. All right, so remember, this is now 1x squared minus 10x and then my number. So unfortunately, I got that middle number again. So guess what? I'm going to have to use our quadratic formula. So I got an x squared minus 10x minus my 7. I'm going to set equal to 0. So y'all, A will be 1, B will be -10, and C will be that -7. Right, here we go. X equals -b, which is -10, plus or minus -10 squared minus 4 times my A, which is 1, and C, which is -7, all over 2 times 1. So let me let y'all catch up on that real quick. All righty, y'all, so here we go. Let's start working this formula down. Negative 10 makes that a positive 10, plus or minus. Negative 10 squared is 100. Now over here, we're multiplying all that together. Negative 4 times 1 is negative 4. Negative 4 times negative 7 is a positive 28. All this over 2. All righty, y'all. So let's see what we get. That 10 comes down, plus or minus 100 plus 28 gives you 128. All of that over 2. So on the side here, what I got to figure out is what is the square root of that 128 going to simplify to. Now, let me move something out of my way here. Remember these numbers: 4, 9, 16, 25, 36, 49, 64, 81, 100, what's next? 121. And then I'm starting to get too big for this radical. But I'm looking for the largest factor in this list. That's the factor of that 128.
64.
Oh, that was really good. Definitely that 64. Good job. That is what? 64 and a 2. So y'all, here's the thing. 4 would have worked, but it wasn't the largest factor. So anytime a 4 works, you're going to check 16. Well, 16 would have worked, but it's not the largest factor. Anytime 16 works, I always check 64. Okay, because 4 times 4 is 16. 16 times 4 gives you that 64. So anytime 4s and 16 works, look at that 64, okay?
Miss McConnell always used to say to start from the bottom.
Yeah, I mean that, yeah, start from the bottom and you can find the largest for sure, okay? All righty, y'all, so guess what? Square root of 64 is 8, so that's going to turn into an 8 square root of 2. So this now gives us a 10 plus or minus 8 square root of 2 all over 2. So remember, all 3 of these outside numbers, if they divide by something, we got to divide them. And these outside numbers will divide. 10 divided by 2 gives you a 5, plus or minus 8 divided by 2 makes that a 4 square root of 2. So you always got to check these 2 numbers on the outside up here. See if they'll divide by that bottom number. If they divide, do that and be done. So watch this one. On this one, remember my numbers were, what did we get? -1 and -2. So when you put the answers in, you can't go with A because there were not only rational zeros. I had those radicals too. So you would have to pick B. The rational zeros were the -2 and the -1. The other zeros were that stuff I got with the radical. So that would be the 5 plus or minus, what I get? 4 square root of 2. So that one, you do have to separate that one into your rational zeros and your radical zeros. Now, when you factor this one out, you're going to have that f of x equals, I got 4 numbers, so I'm going to have 4 sets of parentheses. -2 makes this a x plus 2. -1 makes this a x plus 1. Now on this, I'm going to make the 5 negative on one of them. I'm going to do x minus 5 plus 4 square root of 2. The other one will be x minus 5 minus 4 square root of 2. So the only thing that you change the sign on this one is the 5. Make that 5 negative, and then you're going to have one of them plus and one of them minuses on the radical part.
What if your radical doesn't simplify?
Oh, if you got a radical that don't simplify, then your final answer will be something plus or minus that radical, probably over something like 2 or something.
Okay.
And you'll just have to keep that whole thing in there, okay? So y'all, that was the college algebra part of 8-4. So what I wanted to do, spend a little time and sort of just show y'all what the support was going to do. And really the support's not bad. It was just getting ready for all this foiling. So support for 8.4. So you're going to have examples like this one, and it says multiply. They got a plus p times a squared minus ap plus p squared. So multiply the a times all three of these, then we're going to come get the p times all three of these. So here we go. A times a squared is an a to the third. 1 plus 2 give me 3. Then I'm going to do the a times that negative ap. That's a negative. The a times a gives me an a squared, and then bring down the p. The a times the p squared is a positive a p squared. So notice, all we did, we added an a to all three of these terms. Now we're going to distribute the p, and y'all, I'm going to keep mine in alphabetical order. So the p times the a squared is a positive a squared p. The p times the negative ap is a negative a p squared. So notice all I'm doing is adding 1 p to everybody when I distribute that p, and then that p times p squared is a positive p to the third. Once you multiply, only next thing is to add like terms. So y'all bring down the a to the third. There's only one of those. This negative a squared p, this positive a squared p over here. Those like terms, oops, it was right here, wasn't it? So not there. So the negative a squared p and the positive a squared p, they cancel. Here's a positive ap squared and a negative ap squared. Those cancel. So the only thing at the end left is my positive p to the third. So y'all, this was just getting you ready for foiling like I was doing today. All right, let me try this one. V minus p times v plus p times v squared minus p squared. So I'm not going to lie, on this one, I would probably start right here. Now, y'all, do y'all notice something? V minus p and v plus p. Those are conjugate pairs, right? One's added and one's subtracted. Since these are conjugate pairs, I'm going to shortcut FOIL these. Because remember, the inners and the outers are always going to cancel on conjugate pairs. So if you want to shortcut FOIL, v times v is v squared. And then the last two, the negative p times p is a negative p squared. So that takes care of the first set. And then I'm going to bring down the v squared minus p squared at the end. Y'all, 100%, if you got conjugate pairs, it don't matter if it's radicals, imaginary numbers, regular numbers, or variables. If they're conjugate pairs, you can shortcut FOIL. First times first, last times last. But y'all don't be fooled on this one. These are not conjugate pairs because they're both negative. So this one, I do have to FOIL this one all the way out. All right, let's go. V squared times V squared is a V to the fourth. All I'm doing is adding exponents. The V squared times P squared is a negative P squared V squared. Once again, I'm just keeping mine in alphabetical order. Then I do the negative P squared times V squared. I get a negative P squared V squared. And y'all look here at the end. A negative P squared times a negative P squared is a positive P to the fourth.
I think sometimes they actually count you wrong. Alphabetical.
They do what now?
I said, I think sometimes they count it wrong if you don't put them in alphabetical order.
Yeah, they shouldn't, but MathLab is really, really picky. So by habit, I'm always putting mine in alphabetical order. And if you notice they're doing that, then keep y'all's in alphabetical order too, okay?
And when I first started it was confusing because when I would do it with Miss McConnell, she would just say to do it like you see it so you don't get them confused. But you can't really do that because the computer doesn't accept it. So
No, because if you're doing V squared, P squareds, and P squared, V squareds, and they're out of order, to me, it's more confusing trying to find those like terms. Especially
yeah, that's probably true.
Especially up here with all these A squared P's and AP squareds, and oh my God, that stuff's so jumbled up, it's hard to figure out which ones had the same exponents and all that fun stuff. So, yeah. Now, watch this. Bring down that V4 here. These do not cancel. They're both negative. So a negative 1 here and a negative 1 here makes that a negative 2 P squared V squared. And then at the end, I bring down my P to my fourth. So this is probably how I would put it in. As far as these variables, I'm keeping them in alphabetical order. But the V and the P, I'm going to keep that at the front and that at the end. The only thing I put in order is the actual terms that have more than one variable. All righty, y'all. So they wanted y'all to learn how to FOIL. Because remember, on some of them while ago, I had X minus 2, X plus 3, X minus something else. So they're just wanting y'all to practice that FOILing. And then you had some of these problems where they could sort of get you ready for my imaginary numbers when I was doing them. So here I got a negative 4i times negative 2 plus 8i. All right, so let's see what happens. Negative 4i times negative 2 gives me a positive 8i. And then that negative 4i times that 8i is a negative, let's see, 4 and 8 is what, 32. I times I is an I squared. So what are you turning the I squared into?
A negative 1.
I'm going to turn that into a negative 1. So that's going to give me this 8i. But guess what? Negative 32 times negative 1 makes that a positive 32. Now, the thing we got to do here, we got to write the answer in what they call A plus BI form. So that means the real number has to go first, followed by the imaginary number. So in MathLab, you got to put the 32 first and then plus your 8i. Y'all watch this. We got a calculator that can do those kind of numbers. So let me share my calculator. Let me quit this screen. So right down there where the decimal is, there's a blue I. So watch this. I'm going to do negative 4. I'm going to hit second button and the decimal to get my I. And then I had parentheses, negative 2 plus 8. And then to get to I, I'm going to hit second dot again, the decimal, and close parentheses. Now, when you don't have variables and all you have is numbers like this, you can knock them out on the calculator. And look what we get. 32 plus 8i, just like we had on our problem.
You're gonna have to write me a whole list of all the calculator cheats.
Well, just
I've
remember,
learned
imaginary
so
stuff, I
many.
can definitely do my imaginary stuff on my calculator.
I've learned like so many different ones that like nobody else knew. So and they're probably on Google, but they're hard to find that way.
Yeah, so watch this one. 7 plus 2i times 9 minus 4i. So I'll do this one on the calculator too, because I don't have variables. But I'm going to do it by hand first. So 7 times 9 is 63. 7 times negative 4i is a negative 28i. Now I'm going to multiply the inside. 2i times 9 is 18i. And y'all watch the end. 2y times negative 4i is a negative 8i squared. So this one I got like terms in the middle. And over here, I'm going to turn that I squared into a negative 1 again. So let's see what we get. We get 63. Adding like terms here, negative 28 and 18 give you a negative 10i. But remember, we're replacing the I squared with a negative 1 here. So that negative 1 times that negative 8 is going to make that a positive 8. So do y'all see one more step I could do?
63 plus 8.
63 plus 8. Because after you turn that I squared into a negative 1 and convert that, you're going to have two real numbers here. So 63 and 8 is, oh, what's that? 71 minus 10i. So y'all watch the calculator. It loves those. So I'm going to go to my calculator. So let me clear everything over there and then clear that. So I'm going to put it in just like it looks. Parentheses, 7 plus 2. I is going to be second decimal. Close in parentheses. Open up my next parentheses. 9 minus 4. And then second decimal to get the I. Those parentheses. So we should end up with what? A 71 minus 10i. So, yeah, when it's just imaginary numbers, I love using that calculator. All righty. How about a 9 plus 5i and a 9 minus 5i? So I'm going to give you a couple of these that are conjugate pairs. So remember, these are conjugate pairs. So since these are conjugate pairs, I'm going to shortcut FOIL. Okay. So all we got to do is figure out 9 times 9. What's that? 81. 5i times negative 5i is a negative 25i squared. So let's think of our next step, y'all. Our next step, we got to take care of that I squared. So replace the I squared with your negative 1. And all that negative 1 is doing is turning that negative 25 into a positive 25. And y'all, finally, we can add that. So let's see, 81 and 25, give me what, a 100? Oh, maybe 106. So check this out. When you FOIL conjugate pairs of imaginary numbers, the radicals and the I stuff all cancel, and all it ends up is a single real number. So that's why we love conjugate pairs. You don't have none of that I stuff left. All the I stuff cancels, and all we get is real numbers. So watch this one. 8 plus 4i, 8 minus 4i. Once again, I got conjugate pairs. So I'm going to shortcut this one. And remember, since these are conjugate pairs, we're going to end up with a single real number. So y'all, here we go. 8 times 8 is 64. 4i times negative 4i is a negative 16i squared. Well, y'all, look at that. That's going to give me 64 minus 16 times that negative 1, which is going to make that 64 plus 16. Woo, y'all, let's see what we get. 64 and 6 is what, 70, and then that other 10. So we get what, a single answer of 80. All right, y'all, and I'll say the last one on that section, the last one they want you to solve. They got an x squared minus an x plus 5 equals 0. And I'll tell you the truth too. The reason we gave you this one was to get you practiced back up for that quadratic formula that I had to use to find some of them zeros a while ago. So we're giving you one more problem to practice your quad. So A is 1, B is negative 1, and C was 5. So we got x equals negative b, which is negative 1, plus or minus square root negative 1 squared minus 4 times 1 times 5 all over 2 times my a, which was 1. All right, here we go. Negative negative 1 makes that a positive 1. Under the radical, negative 1 squared is a positive 1. Minus 4 times 1 is negative 4. Negative 4 times 5 is a negative 20. All over 2 times 1 is 2. All right, y'all, so I'm playing under the radical still. So under that radical, 1 minus 20 is a negative 19. All over 2. So on the side, I would play with that square root of negative 19. And y'all, I'm going to tell you the truth. 19 is not dividing by 4, 9, 16, 25. 19 is a prime number. It's not dividing by anything. But there is one thing we got to do to this problem.
Pull out a negative 1.
Yeah, that's going to be a square root of negative 1, remember? And remember, square root of negative 1 gives me my I. So we're just going to pull the negative out, make it an I. So we get 1 plus or minus I square root of 19 over 2. And do y'all remember when we did the quadratic formula, anytime we ended up with the I, we had to write this as 2 fractions. So the first fraction is going to be the 1 divided by 2. Then you're going to write your plus or minus. Now, at this point, I always put my I at the end, but you don't have to. You can do I square root of 19 over 2. It'll take that. But usually I'll do the square root of 19 over my 2. And then out to the side, I put my I. That way it looks like, because remember, they're putting it into this A plus BI form. So the real number is the 1/2, and then the imaginary number, okay? So y'all, that was all support was doing, was getting you really ready for all this foiling and getting you ready for this I squared stuff, okay? Because on my first 3 problems, remember, one of them had radicals and then one of them had all that imaginary stuff.
That problem that I emailed you, what did I do wrong when I entered it?
Do what now?
When I emailed you about the square root over a number that I had gotten wrong, how did I enter it wrong?
Okay, so the only thing that I could tell on that one was your A was 2 on that, and when you was doing the bottom of it, you had an 8 down there somehow, or it should have been 2 times A, which would have made that a 2 times 2, which would have made that a 4.
Oh, okay.
So I think it was just on that bottom was all I could see that you had wrong.
Okay.
So somehow you just got that 4 in your mind and multiplied it by the 2.
All the numbers they get.
Yeah, but everything else is looking really good on it. Okay, so y'all 8-4 is all y'all are doing today. What's tomorrow? Friday. So tomorrow's Friday. We're going to do 5.1 and 8.5. They go together. Actually, 5.1 is doing more domain of fraction stuff, getting us ready for the 8.5 stuff. Then Monday we'll do 8.6, which is a fairly short section. And I'll probably start reviewing for my test 2 Monday, okay? Not my test 2, but my test 3. Okay. And then the last section don't have but like 5 sections, I think, for the last test, okay? And a lot of that last test in the beginning has a lot of calculator stuff. But toward the end, it's got equations dealing with logarithms. So that'll be a new word for you. So yeah, we're keeping it light this week. So tomorrow, 5.1 and 8.5, but they go together, like I said. So questions out of today. So I'm going to stop my